Hey, this is Dave Payne with Elastifile. We're going to spend a little time and talk about Kubernetes and Elastifile, how they work together, both from a configuration perspective and from a performance perspective. So let me take you through some of the components. First of all, if you want to figure out how to use Elastifile in Google Cloud, the inventors of Kubernetes, all you do is go out to the Google Cloud Platform website and do a search for something like Elastifile or NFS. Since Elastifile is a scale-out NFS service that can run right on top of Google Cloud, it can run on-prem, and it can move data back and forth. But if you want to deploy it in Google Cloud, it's really simple. Find the launcher app, and you can read through some of the details for information's sake, but to start, you just hit launch and give it a name. Make sure you're logged into your project. If you're not, it'll log you in anyway. And then you just hit deploy. And once you hit deploy, you'll answer a few questions in the configuration. And within a few minutes, you will have a running deployment in your project. It'll look something like this. It'll have the name of your Elastifile management server. And then at least 3 nodes will be deployed, which comprise the storage nodes that are the basis for the file system. So let's go into this one. Once you have EMS deployed, you just click on the external IP, and that'll pop up our management interface. So the UI is right here. You can see capacity information, you can see performance, kind of configuration information, how many systems are up, how many connections are live, and things of that nature. So out of scope to go through all the details of this UI, but just we'll use this as a basis for navigating around. So now when it comes to Kubernetes, let me show you a little bit of what that looks like. So I have deployed in this project actually a couple Kubernetes clusters that were deployed through GKE. So you go into the Google Cloud Platform, check out the Kubernetes clusters. We're going to be playing in this one right here today for this demo, this K8s-1. So inside of here, you can, if you go down to storage, you can see the storage classes are defined. So once you set up a Kubernetes cluster by clicking the deploy button for clusters, connect to it through gcloud, use kubectl, and you can load the Elastifile provisioner, which makes the connection between Kubernetes and the Elastifile cluster that we just set up. So you can see that we have 2 Elastifile provisioners, one set up for each of the clusters over here. The instructions to do that, if you just do a Google search for GitHub Elastifile provisioner, that'll bring you to this site. And down in the details here, it's got the YAML configuration information. You copy paste this, follow the steps exactly, and within a couple minutes you'll have the provisioner installed inside of your online cluster and ready to go. And then what that does then is when you create a persistent volume, your pods can then make persistent volume claims against Elastifile, and what it does is it goes in and it creates data containers automatically for your pod, calls them PVC, and it gives them a UID, then configures them according to the details you have in your YAML file for the pod. So for example, let me pop over to a Kubernetes cluster here. So we'll take a look at some of the ones we have configured. So we'll get persistent volume. So here's a cluster. You can see I have several PVCs set up. Some are bound and some are released. These are the ones that are active right up here. So you can see these names 192 detail. There's a 50 gigabyte and 220 gigabytes. They're claimed. You can see which pods they're claimed by or which deployments they're claimed by. There's one MySQL, one for WordPress, and one for WordPress shared here. So if I take a look at those and remember basically those names, I'll pop back over to the Elastifile console, and you can see that here's a couple. They're actually all 3 are right here. Now here's one of them, at least 192.858. That's the 50 gigabyte volume. So what this did is programmatically it created a data container, which is essentially a container for data. It's our word for essentially a file system. So we treat it as a management unit. So you create a data container, turn on things like dedupe and compression, give it a size. This one's 100 gigabytes. And Once you have it, you can configure policies on it, things like replication, snapshots, and then you can export it with NFS attributes for clients. So all of this is done automatically through the provisioner. Okay. All right. So let me back out to here, and we'll go back to Kubernetes. Now we'll take a look at what's running on this pod or on this Kubernetes cluster. So we'll get pod. There we go. So you can see several pods that are running here. You can see the provisioner actually runs as a deployment on its own, and then that's how it's added to the other containers. You can see the WordPress. This is a WordPress site that's running as a container, and WordPress actually needs a file system to store all of its unstructured images, and then it also uses a database that needs stateful storage in order to store all of its content as well. So this is a great use case actually for Elastifile, and our provisioning system is we provide state for stateless containers. So let's log into this WordPress machine itself. So if I actually look inside of this, I can see what's mounted. So from within the container itself, I have two mappings. These are NFS mappings that go through Kubernetes. They hit the Elastifile server. You can see both of them set up. One of them mounts to /HTML, and one of them mounts to /WP content. We'll take a peek inside of this one here. So you can see that inside of this, we've got this uploads directory, content. I'll hit enter there, and so remember these kind of words: daisy, dandelion, roses, sunflowers, and tulips. Okay, so there's actually inside of one of these, we'll peek into daisy. Okay, so you see a bunch of picture files. You see all these JPEGs. So running, we actually have a little kind of a sample WordPress site running, and so in this gallery, it's a photo gallery site. If I click daisy, you'll notice that we have a whole bunch of picture files. So those files are actually being stored on the Elastifile file system. These are stateful files. So if the container were to go down and need to come back up, the state is kept within that directory system. Okay. Also, since it's a deployment, if we scale the Kubernetes deployment, and then I need to get out of the machine first. There we go. Require 2 replicas. There we go. All right, so now you have a second replica being created, and this replica will also have access to the same resources, and we'll be able to can scale our website out and the like, all sharing the same resources behind the scenes. So I have another deployment running on Kubernetes, and this one here. Okay, so we have this one called DB. This is actually running an Elastifile application called eRun, and eRun is designed to make many connections to an NFS backend and generate any type of a load that you like, whether it's large block, transactional, multiple connections, single connection, lots of capabilities there. So we designed this one to really throw a lot of load at our Elastifile server and push the boundaries of it. We run it inside of a container here, so we can actually dynamically expand the load kind of on demand. So right now this one's running, and if we go back over to Elastifile, you can see that we have 13 connections to our Elastifile cluster at the moment. We'll bring up a view of this with performance. And so you can see, how much throughput is going right now. We've got throughput measurements, how many IOs per second are going on, and then what the latency, the total aggregate latency is of the entire system. And you'll notice that the big numbers, the aggregate number, and the smaller numbers are very small. I'll make them bigger, but they are the combination of read, write, and metadata attributes. Okay, so this is one system running, and it's generating X amount of load right now. This is pretty much it as our baseline. So let's increase that. So we'll increase it with the same commands. We use the scale command, and we'll scale the deployment. We're going to do 2 replicas of the DB. So that's now scaled, and you'll see when we get pod that we have 2 DB pods running, and we'll see pretty quickly as this real-time graph updates that the load will start to increase, and we will respond to that by giving more performance out to the application. So you'll see now we went from about 700 megabytes per second up to 1 gigabyte per second. Okay, so this is pretty well stabilized at a gigabyte per second. So let's double that again. So we'll scale it up to, and from 2, let's go to 4. And you can see the containers are already created. It takes essentially no time at all. Let's go to 16 replicas now. All right, we've stabilized at just about 4 gigabytes per second with, I think that was 16 connections. Let's jump this up let's go to 24. So let's see, we're hitting 4.4 gigabytes per second. We're seeing a nice linear up and to the right flow. Well, let's add a little more load to this thing. What do you say? How about we go to next magic number, 32. Okay, so that's how we scale Kubernetes. It's really nice that it can access the stateful information coming off of a Elastifile cluster, which again, this model could be applied to any application that needs to keep state. And Elastifile as a performance profile would work really nicely for both throughput-oriented applications that are traditionally designed for NAS or work well with NAS, and also transactional applications like databases. You can see with a low latency transactional kind of platform like Elastifile, it's actually a really nice way to take traditional IT applications that work either on SAN or NAS and migrate them over to cloud like Google. So thanks for watching this demo on Kubernetes, Elastifile, our provisioner, all running inside of Google Cloud.